again! Gene! 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 We're out of water again!
In our part of the world, water seems plentiful. However, we need to conserve and protect the water resources we have. With careful planning, construction, and management of wells, you can help ensure a continuous and adequate supply of clean water. When you are changing water and land use, your district agricultural office can be a good source for information.
Hi, Norm. You said on the phone that you were having some concerns about your water.
Well, with my son planning on moving back to the farm, along with his wife and kids, along with the expansion of our cattle operation, we thought we'd better get a handle on the water supply. Come on in.
We've done some thinking about the water. It's not just having more cattle. You see, when Jim and his family move back, they're going to be living in this house, and we're going to build a smaller one down by the creek.
If that happens, I think we're going to need a new well.
Yeah. We need a deeper one than the one we've got. I am tired of competing with the cows for a glass of water.
It's pretty stiff competition. Before you can decide what's best, we'll need to take a look at the geography of the area, the type of aquifer you have.
Why bother with all that? We can just call a driller.
Wouldn't a driller know all that stuff?
That's true. But you'll be paying a driller a lot of money to put in a well. It's a good idea to know as much as you can about what you're paying for.
You're right. I don't like to give money away for things I'm not sure about.
Approximately 6,000 new wells are drilled each year in Alberta. For rural people and small communities, groundwater is usually the only economically dependable source of water. Groundwater, which is simply water stored underground, makes up just 3% of the water in Alberta. However, with so many people relying on groundwater, it is extremely important that we understand, conserve, and properly manage this precious resource. The groundwater we use and often take for granted is part of a complex cycle known as the hydrologic cycle or water cycle. Much like a bank account, there's a continuous balance of deposits and withdrawals, recharge and discharge. Water falls to earth in the form of rain or snow. It runs off into streams, rivers, and lakes, or it seeps through the spaces and cracks in soil and rocks. Through evaporation from lakes and rivers and transpiration from plants, water is returned to the atmosphere and the cycle repeats.
We need to estimate the amount of water you're going to need, and we'll need some information on the bedrock and on the water tables.
How do we do that?
Well, we can check some of the geological information I brought along, or you can get other information by talking with some of your neighbors and by checking with some of the water well contractors that work in the area. The provincial government has a groundwater information center. Here's the number. Meanwhile, let's take a look at some of the aquifer information I have here.
An aquifer is an underground layer of porous or fractured bedrock, sand, or gravel that contains water. The idea that when you drill a well, you tap into vast underground lakes and rivers just isn't true. The type of material that the water filters down through can also affect the quality of the water in the aquifer. If the material is very dense, such as clay, it takes much longer for water from the surface to percolate through to the aquifer. The water that seeps down recharges the aquifer, and the materials it goes through also act as a filter to purify the water. Alberta has several different types of aquifers. The most common are sand and gravel deposits that are often near the surface, or sandstone, fractured shales, and coal in the bedrock. Before you construct a well, it's important to understand the types of aquifers in your area, since it will affect the construction of the well and the amount and quality of water. Aquifers vary in size, depth, thickness, and water quality. It can take only a few minutes or up to 100 years for water from the Earth's surface to reach an aquifer. Alberta has very few high-producing aquifers. However, there are numerous aquifers capable of meeting the needs of farmers and ranchers if properly managed and maintained. Therefore, it is important to protect and conserve the groundwater sources we do have. The quality and quantity of water a well produces depends a great deal on the aquifer. A fine sand aquifer and a coarse sand aquifer may contain the same amount of water. However, the spaces between the coarse sand are greater, so water moves more easily through the coarse sand and into the well.
Okay, let's get an idea of how much water you're going to need the well to provide. Human water requirements are estimated at about 230 liters per day.
That seems like an awful lot of water.
Well, when you add up all the water needed for drinking, cooking, cleaning, showering, flushing toilets, cleaning machinery, watering the garden, it adds up pretty quick. Now, beef cattle require about 70 liters per day. Are you planning on adding any other livestock? Chickens, pigs, horses? With the information we have now, there are several options on the type of well you can construct. No matter what type you choose, in order to prevent contamination and protect against well failure, it's important that the well is properly located and constructed. Let's take a walk and check out a few things.
There are a number of government regulations regarding the distances between wells and possible sources of contamination. A well needs to be at least 10 meters or 30 feet from any septic tanks or sewage holding tanks. To help prevent contamination, the well needs to be located on higher ground than the surrounding area, and all surface runoff should be directed away from the well. It should also be away from any livestock operations. In order to prevent problems in servicing, the well should also be at least 3 meters from any building and 15 meters from overhead power lines. The fuel storage tanks above ground need to be at least 50 meters away from the well.
Well, I think you made a good choice. I think this is an ideal spot for the new well.
You know, it used to be so simple. You'd call a driller and drill a well. I never realized that there was so much information to consider.
That's why it's important to do the research we've been doing, so that you can make an informed decision. Another important factor to consider is the number of different ways to construct a well.
One option is a large diameter bored well. This type of well is constructed using a rotary bucket auger. The depth of a bored well is usually not over 30 meters. Bored wells are primarily used in slow-producing shallow aquifers. The large diameter casing helps to store extra water to meet some of the peak demands for farm water. One of the more popular methods is rotary drilling. This uses a rotary bit on a drill stem. Construction can be done quite quickly and to depths of 300 meters or more. Cable tool or percussion drilling is another method for constructing small diameter deep wells. There are several other construction methods, but the most important thing to remember is to use a licensed driller. Proper construction and maintenance will help your well to have a long and trouble-free life.
From what we've gathered, a rotary drilled well is best suited for our situation.
It'll go deep enough to give us a good water supply.
I agree. I think the next step is to talk to a certified water well driller about construction options and the price of your new well.
It's very important for the client to understand his well. It's important for him to understand the well before he has it drilled so that he knows that things are being done properly. The driller should know, and in fact the majority of them do know, the basic standards that are required for proper well construction, but every industry has its fly-by-nighters who do substandard work. That is a major concern, being that we're dealing with a resource that's critical for life. We need to protect it by ensuring that work is done properly. The best way to ensure that is the same situation as if you were buying a car, if you were buying a house, if you were buying any piece of equipment for your farm. If you know what you want and how you want it to work before you buy it, you can ensure you buy the piece of equipment that's going to do the job for you. Your well is one more piece of equipment on your farm. There are basically two parts to a water well. The first part is the surface casing, and the purpose of the surface casing is to keep out contaminants and to protect the pumping equipment which is going to be installed in that portion of the well. The second portion of the well is the production zone, and the production zone is constructed based on the type of material that the formation is made of and the type of aquifer that we're working with. In the construction of the well, it's very important that we consider that this well is going to be here for a long period of time. In order to do that, we need to maximize our production and minimize drawdown. Drawdown is the lowering of the water in the well during pumping. In order to do that, we need to use some basic technical data which has been proven over time. And the basic considerations are we want a minimum of 0.01 feet per second intake velocity. That's in our production zone. We want no more than 5 feet per second uphole velocity in the water when we're pumping it. And we want a well casing which is at least one nominal size larger than the pump. Those factors are critical to the proper development, proper use of the well. Development is a reasonably technical portion of completion of the well. It's important that development be done properly. In order to start developing the well, the first thing we need to do is produce water to make sure that we've got water coming through our screen. And in that portion of the well, we will do what's known as overpumping, which is simply producing water from the well at a greater rate than what the customer is going to use at the end. Now what we're hoping to do, of course, is have a formation that will yield us more water than we require. What we're trying to do is determine a couple of different factors. We're trying to determine how efficient the well is. And to do that, we'll compare how much drawdown we have in the well for the production rate and a comparison to what we would expect that aquifer to produce. The other thing that we're looking for is some information that we can make some long-term predictions as to how effectively this aquifer is going to handle being used. And in order to do that, we need to record over a set period of time how much drawdown we have in the well at a given pumping rate. Probably the biggest concern that we have with contamination of our resource. The groundwater resource is a critical resource. People cannot live without water. And our concern is to avoid contamination of that resource. The biggest danger in contaminating that resource is poorly constructed or improperly abandoned wells. Those wells give a very good conduit for contaminants to get from surface into the water-bearing zone. The earth itself is well enough put together to avoid most of these contamination problems until we start drilling holes and making conduits. Disinfection is very important. We try to maintain as clean of fluids as possible in the drilling situation. There are problems with contaminants picked up from the soil itself as we drill the hole. Our drilling fluid is chlorinated to a level of about 50 parts per million, which controls the bacterial content in that fluid itself. Once the well is completed and it's been washed out and developed and tested, then we'll raise the level of the chlorine residual to 200 parts per million in the well, and we'll leave that sit for at least 24 hours so that the bacteria is completely killed off and we have a clean well. Steel is used in situations where we need to be able to be a little rougher with the casing when we're installing it. But plastic is taking the place of steel in the market. And the big advantage to plastic is that it's very resistant to corrosion, therefore we get a much longer life expectancy out of the well. Plastic does have the drawback that it's substantially weaker than steel, so we can't be as rough with it in handling, and there may be some limiting factors in the development phase of the well.
The contract is all signed. The driller will be here tomorrow. We should have a new well by next weekend.
I'm glad we took time to do this properly. This well's gonna last a long time. I don't understand what's wrong. We had a routine chemical analysis done by a local health unit last year, and the water was okay. Now, we don't get as much water, and what we do get isn't the best looking or tasting.
A routine chemical analysis will identify the mineral characteristics of your water, such as pH, iron, hardness, and total dissolved solids. However, this type of analysis doesn't check for biological contamination. Now, your water may look and smell fine, and it may be okay chemically, but it can still be contaminated with bacteria. This is where a biological analysis will come in handy to identify any potential biological problems. Norm, have you done any work on the well since you had the analysis done?
I pulled the pump last summer.
Something as simple as putting the pump down on the ground while doing regular maintenance can introduce contamination into the well. That's why it's very important to make sure you disinfect anything that goes into that well. However, that doesn't address your yield problem. Let's go take a look at the well.
To have a well with good water yield and to prevent contamination, there are several things to consider. Where is the well located? Is it far enough away from sources of contamination?
Location of your well looks okay. Distance from the livestock facilities, the septic tank area, they're all within the required limits. It's up high enough so that there's proper runoff in the event of rain or when the snow melts. What about fertilizers, pesticides, fuel and petroleum products?
We're very careful about that. We mix them according to directions and dispose of the containers the required way. I took a pesticide management course about a year ago. It really opened my eyes to some of the potential problems we could have had.
It's our responsibility. We can't afford to be careless.
Well, you certainly seem to have your pesticide question in control. What about your fertilizer and fuel storage?
Your above-ground fuel storage tanks should be at least 50 meters from the well. You should avoid fuel spills, and used engine oil should always be disposed of properly.
We do try to be careful with our fuel and oil. And as far as fertilizers are concerned, we only buy what we need each year, so there isn't much need for storage.
Another way they become contaminated is from unused wells. Do you have any old wells?
Wait a minute.
My father dug this well back in the 40s, probably. We haven't used it for years.
Well, it's very important to properly reclaim or plug any abandoned wells. Now, you're definitely going to have to bring someone out here to properly reclaim this one for you. This could be a source of contamination for your aquifer. It's like a pipeline for bacteria, pesticides, even livestock manure to get down into the aquifer and affect your existing well. It can also be a safety hazard for children, for small animals. That's especially true for these large diameter wells.
What's involved in reclaiming a well?
The procedure depends on the type of well and on the aquifer. You should talk to a qualified water well driller. He'll be able to help you properly reclaim this one. But basically, there are about half a dozen steps involved. First, you need to measure the well. You can often do this yourself or check back into the farm records to see what the dimensions are. Second, you need to clear the well of all debris, anything that's managed to get down there over the years. Remove all the old pumping equipment. Once the equipment's been removed and the well's been disinfected, a material impervious to water, such as bentonite or cement, must be pumped into the well from the bottom up. Now, this will ensure a proper seal is formed. It's essential that a material be used that will not allow surface water to flow down into the aquifer. Do not use sand or gravel. The final step is to mound the surface so that water will run away from the site.
Another problem if you have an older well can be the well pit. Well pits were usually constructed to hold pumping equipment below the frost line to keep it from freezing. Well pits are no longer legal on new wells in Alberta. A pitless adapter makes a sanitary, frost-free connection for the pump through the well casing.
The well pit can be a source of water contamination. Runoff water or contaminated groundwater can seep into the pit. Mice and other rodents can fall into the pit as well if it's not properly covered.
Well, this all helps us understand any potential water quality problems, but why aren't we getting the amount of water we used to?
There are a number of things that can cause a significant reduction in your well yield. Some of these include mineral incrustation, biological incrustation, sediment plugging. With some or all of these factors potentially working against you, it's critical that you keep up a routine monitoring schedule to make sure you catch problems before well failure occurs. Now, do you happen to have your records handy that show the yield when you first had the well installed? Okay, when was the last time you checked the water level?
Not since we put the well in 5 years ago.
Okay.
When the well is completed and before the pump is installed, the well is required to be thoroughly tested for performance. This involves pumping for 2 to 4 hours. With the calculations from the testing, the drawdown and yield can be calculated so a pumping rate can be determined. The drawdown is the difference between the static water level and the pumping water level. Water level in a well should be regularly monitored. The water level in a well should not fall below the top of the screen or perforated pipe. Water quality testing and monitoring the water level in your well on a regular basis can warn you of overpumping and help prevent well failure.
Okay, we'll have to wait a few days to get the test results back from the lab to get a complete picture on your water quality. But from the monitoring we did today on your wells, it appears that your yield problem is probably due to a combination of things that we discussed. The slime buildup on the side of the tank is a good indication that iron bacteria is present and could be part of your yield problem.
How's that bacteria get in our well?
Bacteria are present in all soils and can get into a well when a pump is being installed or serviced. Laying the pump on the ground may have contaminated it. Sometimes the well is infected when it's being constructed. It's another reason for using a qualified journeyman driller. Drillers are required to disinfect their equipment.
What are we going to do about it now?
Well, as I mentioned earlier, iron bacteria isn't considered a health hazard, but it can be an expensive nuisance. The recommended treatment is shock chlorination.
The well provides both a good conduit and perfect environment for several kinds of bacteria. One of them is called Gallionella, or iron bacteria. Gallionella is a bacteria that feeds off iron in the soil. If these bacteria manage to get down the well and into the groundwater, they'll find iron, their food source, either dissolved in the water or in the metal well casing. They will also find a constant year-round temperature, total darkness, and small amounts of dissolved oxygen in the water. For them, an ideal environment to grow and multiply. The presence of iron bacteria in the water does not threaten the health of people or animals. It is more of a nuisance than a danger, and many people simply decide to live with it. But the nuisance factor can sometimes get out of control, and when it does, you'll know it. The bacteria forms a rust-colored slime that coats anything it comes in contact with. It can be seen on the inside of toilet tanks and pumping equipment. The high concentration of iron will also stain bathtubs and sinks. They can also alter the color, odor, and taste of the water, as well as foods cooked in that water. Tea will be much darker than normal, and potatoes will tend to turn black as they are boiled. At their worst, these bacteria can reduce water flow into the well or plug pumping equipment, affecting pump performance. The first line of defense against iron bacteria in your water supply is prevention. When the well is first drilled, ensure that the driller disinfects the well before he installs the pump. If the pump is pulled from the well for servicing, be sure to thoroughly disinfect it and any other equipment before it is put back down your well. Properly seal the top of the well to prevent anything from entering the well casing. A well is like an expressway for bacteria, along with chemicals and other pollutants, to get from the surface to the groundwater. Once it's down there, it can travel through the aquifer and infect other wells. So proper well maintenance can prevent problems with your neighbor's water supply as well as your own. Gallionella can be controlled by a process called shock chlorination. Shock chlorination can easily and safely be done by the homeowner. There is no need to hire an expert. It involves introducing a measured amount of a chlorine solution into the well to kill off the iron bacteria. The process can be broken down into 9 steps. Store enough water for your use while the well is being chlorinated. The process may take up to 48 hours, so enough water must be stored to cover that period. Collect twice the amount of clean water as is stored in your well casing. The water volume can easily be calculated from a table. For example, a 6-inch diameter well with a 100-foot depth of water will require 200 gallons of stored water. The water should be stored in a clean container near the wellhead. It doesn't have to be fancy. A pickup truck or aluminum boat will do the job. It bears mentioning that a sprayer tank should never be used for this purpose. Contamination from pesticides and herbicides must be avoided. This looks like a fuel tank, but it has only ever been used for the storage of clean drinking water. Mix the recommended amount of bleach, powder, or chlorine concentration into the stored water. A concentration of 1,000 parts per million is required to effectively treat the water supply. Siphon or drain the solution into your well. A word of caution: if the well tends to pump sand, run the bleach solution down the well slowly to minimize disturbances in the well. Open each outlet in the house, one at a time. Run each faucet until chlorine can be detected. Chlorine has a pungent swimming pool smell and gives the water a slick, slippery feel. Don't forget the toilets, washing machine, and dishwasher. Some water treatment equipment can benefit from the chlorine treatment. Others will be damaged. Check with a water treatment equipment dealer before introducing the chlorine solution into your treatment system. Leave the chlorine in the well for at least 8 to 48 hours. The longer it's left in, the better. Prevent anyone, including animals, from drinking this high chlorine concentrated water. After a sufficient amount of time, open an outside tap and purge the chlorine from your system. A few notes of caution: the large amount of chlorine in the water will kill the beneficial bacteria in your septic tank, so don't purge your water system into a drain. Let the water run onto the ground in an area where it will not harm plants or animals, and don't overpump your well. Run the tap until the slippery feel and swimming pool smell disappear. The chlorinated water in the toilet tanks can remain there until the toilet is used. The small amount of chlorine in the toilet tank will not harm the bacteria in your septic tank. Run your filter system through another cycle, this time to rid the filter of the chlorine solution.
As far as some of the other problems are concerned, you're not in that bad of a shape yet. Comparing the well readings we took today with those of the original well driller's report, we can see that your static water level hasn't changed that much since the well was first drilled. There are 2 situations which can result in significant water level declines in your well. The first results from pumping a well at a rate higher than the well is designed to deliver. This is exceeding the well capacity. The second results from pumping the well at a rate that exceeds what the aquifer can produce on an ongoing basis. This is exceeding the aquifer yield. If the water level declines sharply when you're pumping, it could reach a level where the pump breaks suction. At this point, little or no water is produced, and worse yet, the pump may burn out. When pumping stops, the water level rises back to where it was before pumping started. Now, this usually indicates that the well is being pumped at too high a rate, thereby exceeding the well capacity. Now, by reducing the pumping rate, you usually solve the problem.
What if you can't reduce the pumping rate?
Well, in some cases, a storage cistern may be required to allow pumping to spread over a longer period each day.
What if we exceed the aquifer yield?
If the static water level is gradually declining each time you measure it, you may have overpumped the aquifer and exceeded the aquifer yield. Now, this is a much more serious problem. If the average amount of water being pumped isn't reduced, your well will go dry.
Which means drilling a new well, right?
Well, drilling a new well into the same aquifer won't solve the problem if the aquifer's been pumped dry.
It sounds scary.
Some aquifers are just not capable of supplying the amount of water required. If that happens, an alternate source of water is needed.
So the size of the operation should be scaled to the amount of available water.
Exactly. Your water supply could be the weakest link in your entire operation. Now, I've provided you with a lot of technical information to impress upon you the importance of measuring your water levels in your well on a regular basis. The information can tell you a lot about your water supply and can give you advance warning of well failure. This way you can plan ahead and not have your well fail on you when you need it the most.
There are ways we can cut back. I guess we just weren't too concerned. The water always seemed to be available.
I agree. We can watch our water use more closely.
Water conservation is always a good idea, and it's not as inconvenient as most people think. But I don't think your well is going dry. I think your problem probably stems from too high a pumping rate. If you reduce your pumping rate and properly adjust your restricting valve, it should eliminate the problem.
Properly monitoring and maintaining your well will save a great deal of time and money during the life of the well, while ensuring an adequate and long-lasting supply of good quality water. The careful use and protection of groundwater is not an option. Our future depends on it.